Hi everybody, John Accardo here again, and welcome to part 4 in this series covering the FS200 clamp-on utility software. In this segment, we'll discuss the diagnostic capabilities of the FS200 utility, including how to view your signal graph and how to interpret it, and also how to run a diagnostic report and evaluate the diagnostics that you're seeing. To use the diagnostics portion of the FS200 utility, you will have to have a live connection to your flow meter. In order to do so, you'll need a Type A USB cable. Plug the standard end into your USB port on your PC and plug the Type A connector into the USB service port on the FS230 flow meter, which is located directly above the display. Once you've connected your cable, come up to the Setup tab at the top of the screen and click it. Then click the Communications. A dialog box will open where you can verify your device address, your baud rate settings, and your COM port. Make sure your device address is 1 for a direct connection to the flow meter. You can then verify your baud rate and your COM port settings. We generally work with a baud rate of 19.2. The Connect Using box should be indicating the COM port in which your USB cable is connected, but just be sure to verify that it is the correct one. Once you've verified these COM settings, just click OK. Now come up to the Connections tab and click Connect. Another dialog box will open, which will show the connection status. Just click OK and the tool will connect directly to your flow meter. When that dialog box goes away, the connection is established. Now you can access the Diagnostics tab and click it. And when you do so, you'll have two choices: the signal graph indication or the meter diagnostics. So let's start with the signal graph. When we click it, a new window will open. The FS200 tool will begin to gather data from your flow meter as indicated in the bar at the top. Once it's done so, it will then present a live indication of your signal graph. This is your receiver signal of your transducers communicating across your pipe. And you're actually seeing two signals here superimposed over the top of one another. You're seeing your upstream signal and your downstream signal. But presently, because there's no flow in the pipe, they're directly on top of one another and there's no time differential. In the center part of the screen, you'll see some of the diagnostic values associated with your signal graph. You'll see the RX gain up and the RX gain down, which are your signal strength indications. You'll see your signal to noise ratio for both upstream and downstream. And you'll see your current flow velocity measurement, which is basically 0 right now, and your speed of sound in meters per second. So right now we have a sonic velocity of 444 meters per second. The meter status is measurement, so there's no issues presently with your flow measurement. It's in measurement mode. There are no alarms present. And we even show you the frequency at which the meter is operating or which it's transmitting to the flow transducers. On the right side, in the right column, you can see the travel time up versus the travel time down. So that's the propagation time of the ultrasonic signal from the upstream transducer to the downstream transducer, and vice versa. And you can see they're both essentially identical, which means that there is no flow in the pipe. And obviously the delta time, the difference in time between the two, is 3 nanoseconds. So there's no flow. Another thing you see here is something called the correlation Q, which when perfect is 1.0. So we're virtually perfect. We're at 0.99. And that's an indication of the quality of the received signal. Basically what you're looking for is everything is green. And that's indicating that there's no issues. If an operating condition becomes marginal, its indication will turn yellow, and if it's below recommended minimums, it will turn red. So it's very quick and easy to see operating status. If we look at the receive signal, what we're looking for is on the left side of it an essentially flat line. The transmit signal occurred way off in the distance to the left here, and the sonic beam was traveling across the pipe and arrives where you first begin to see it break from the baseline. The window that you're seeing here on your signal graph display is predetermined by the flow meter. It has to do with the accepted time frame in which that received signal can arrive. So you're not seeing the full transit time across the pipe, you're seeing it just slightly before the signal is expected to arrive. And so during that time, we don't expect to see any signal at all. It should be a straight line, which we're basically getting here. And then the received signal arrives, and you see the energy of the received signal building up. In general, we like to see the received signal reach full amplitude by the 5th cycle. That indicates a good quality match to the pipe that you're installed on. And that's a textbook condition for a transducer receive signal. Once we peak, that's essentially the end of the transmission energy, because the transmission signal is only 5 pulses. So each pulse, as it arrives at the receiving transducer, arrives in phase with the previous pulse and causes the energy to build. By the 5th cycle, we're finished with the arriving signal energy, and now the signal begins to ring down and goes back to a baseline condition again. So what we're seeing here is an ideal wave shape. We've now begun to run some flow through the pipe. Again, if you look at the center part of the screen, you'll see that the flow velocity is now indicating 2.6 meters per second. And our delta time has now changed. There is now a difference in time between the upstream signal and the downstream signal. In this case, it's 230 nanoseconds. So that is definitely an indication of flow. If you look at the waveform itself, you can kind of see a double image. But we can make that clearer by expanding. By clicking the zoom in button at the bottom of the screen, we can enlarge the signal, and then we can move the slider to recenter the signal on the display. And you can now clearly see the time difference between the upstream signal and the downstream signal caused by flow. The greater the flow, the bigger that time difference will be. So if you're on a gas application that's flowing at a very good velocity, it's very likely that you'll see multiple cycles of phase shift. Right now you're only seeing a fraction of a cycle of phase shift. It's very small. But on large gas pipes, especially when high flow velocity is present, you'll generally see multiple cycles of phase shift. Here's an example of just such a condition where high flow is creating a large phase shift between the up and downstream signals. If that becomes difficult to analyze because of the cycles interfering with one another, you can come up to the top and click this box marked correlated, and that will realign the signals together to make them easier to verify. It'll take away the phase shift. But we'll uncheck that for now. You could see your phase shift. And now if I stop flow, we'll see that that delta time will actually go away. And the two signals will return to being in phase with one another. Your delta time will go back to basically 0, and you'll have the fact that there's no flow. So that's the way an ultrasonic meter works. It measures the time in one direction, the sonic transit time in one direction, versus the sonic transit time in the opposite direction. And when flow is pushing on the signals, one begins to arrive sooner, the one that's going downstream, and one begins to arrive later, the one that's going upstream, and there's a difference in time, which you just saw on the display. And that is flow. If you want, you can change the zoom factor to get a better view of the signal, and you can also print this display so you have a record of what your signal looks like. We covered printing in the sizing segments of this series. So you might want to check that, but basically just click the print button and the tool will print to whatever printer you already have configured in the FS200 utility. What the signal graph tool will also enable you to do is if your flow meter is configured for more than one measurement path, you can view the individual receive signals for each path by just simply coming up to the top and clicking the radio button for the associated path. Once you're finished with the tool, you can just click the exit button and that will exit you out of the signal graph tool. The other function you have available to you in Diagnostics is the meter diagnostics. And if we click that, we get a live presentation of the current meter variables that indicate the quality of the operation of the flow meter. These are pretty much the same ones you just saw on the signal graph. So we have our signal strength, our RX gain up and down, which are generally exactly the same. Our signal to noise ratio up and down, and again, those should be very close to one another, and they may just alternate a little bit. You'll see your measurement status, and if there was a fault condition, you would see that, and I'll be able to reproduce one of those for you in a minute. You see your correlation Q, which is your signal quality. Again, 1 is perfect. And something called percent accepted, which means that every transmission that's performed by the flow meter, every time it transmits to the transducer and receives back, it analyzes that received signal to make sure it's suitable for use. And this 100 means that every single transmit cycle is acceptable and being used for measurement. Again, we see our delta time, which is the difference in time between the transmission downstream versus the transmission upstream. And because we're at zero flow right now, it's effectively 0. And you can see that it's in microseconds, and 0.004 means that it's 4 nanoseconds. So we see our measured flow velocity, and we see our speed of sound in meters per second. So let's now take a look at an application where things aren't so good. Here you can see everything isn't green anymore. We now have a couple of red indications. Both the RX gain up and the RX gain down are in the red and showing fail because of weak signal strengths. We also see that the signal to noise ratio is toggling between green and yellow, so it's in a warning state. You see that the status is still measurement, which means that the meter is still able to work, but it is operating marginally right now with low signal strength and poor signal to noise ratio. So by using a simple red, green, yellow approach to indicating conditions, the FS200 tool will identify marginal conditions that need remedial action. Once the marginal condition is remediated, the tool will then indicate the improvement that was made by showing the change in the values and changing back to green, hopefully. So such a condition of a weak signal and a marginal signal to noise ratio could be just poor coupling of the flow sensors to the pipe wall, or in the case of a gas application, it may be that the pressure is too low and so the gas isn't dense enough to conduct the ultrasonic signal. Once remedial action is taken and the conditions improve, you can see that everything goes back to green again. Also, if you'd like to know what your actual pass-fail limits are, you can review them, and you could even change them somewhat to match up better with your application by simply exiting out of the diagnostic tool and coming up to the setup section of the screen, and you'll see that there's a location there marked pass-fail limits. So if we click that, we'll see all the different parameters that are shown in the diagnostic screen and what their current warning limit values are, which is where they'll turn yellow, and what their fail limits are, which is where they would turn red. You can in fact make an adjustment to those if necessary because your application operates closer to a limit, But for the most part, it's better to just leave them as they are. So let's exit back out of here and return back to the diagnostic screen. And again, everything is good once more because we've remediated the application issue. Let's continue on now with our look at the diagnostic screen. At the top of the screen, we see flow rate indicated in cubic feet per hour, and we see our standard volume flow rate in standard cubic feet per hour, and that takes into account pressure and temperature. At the bottom of the screen, you see an automatic graph of the flow, and in this case, it's flow velocity. We can change what's displayed on this graph by coming up here into the center and hitting the drop down and choosing between flow velocity, flow sonic velocity, the signal strength values, the flow rate, or the standard volume flow rate. So let's just pick flow rate. We'll change the parameter, and then we can also set the scaling. Right now it's auto scaling, so it looks like the meter is very unstable, but it's because the difference between the minimum and the maximum is very small. So if we put our actual range in, let's say we're 0 to 100, and hit enter, and then we have to click the manual scaling radio button for the manual Y scaling, and that will now rescale the y-axis to the values that we just entered, which gives us a little bit more of a stable reading on that graph. Another function that the diagnostic tool gives you is the ability to do data capturing. If you look up in the top left quadrant of the display, you'll see where there's a file name and a directory. You'll also see at the top of the screen it says gathering data from meter. So this is continuous. The FS200 tool continuously gathers data from the flow meter and presents it live on this screen. What you can now do, if you'd like, is to create a data file to your PC. And if you notice in the file name section, there's already a value there, and it happens to be the date and the time, and it's a CSV file. You'll also see that there's a time interval selection. So if I click the drop down there, I have a choice of different time intervals of anything from 30 seconds to a minute, to 30 minutes to an hour, and even unlimited, which means that you can continuously capture until you tell it to stop. So if we just do a 30-second capture and hit start, what will happen is a file will be created by this name. Now we can amend that if we want. I could just say it's test underscore date and time. If we want, we could identify a specific directory or a specific path for the location of this file. So if we choose a particular location on our PC, we can put the path in there. If we don't put anything in that path, then the file capture will go into the FS200 Utility folder. So let's just do that. Let's just leave it alone, and it will end up in the FS200 Utilities folder. And if I hit start, you'll notice at the top of the screen that will change from gathering data to capturing data. So now it shows you capturing data from meter, 30 seconds left, and it begins to count down. And it's running a trend, capturing all this data and creating a .csv file, which is suitable for opening in Microsoft Excel. Once it counts down to 0, it will revert back to gathering data from meter, and that file will be closed. So you see now it's completed the capture. It's now back to gathering data from meter. The file it created is now closed. And if we now exit this screen and go to, there it is there. So here's my location, my FS200 Utility folder. If I open it up, there's the file that we just created, test, and the date and the time, and it's a CSV. So you can now open that directly in Excel. And if I do so, I'll right click it, I'll say open with Excel, and we'll see the data we have. So there's our file, and you'll see it says Siemens Data Capture Log. It gives me my product number, COM settings, the size of the pipe that we're on, the pipe OD, pipe wall thickness, pipe inside diameter, what transducer is being used, the path setup, the mounting mode, the sensor spacing, speeds of sound, limits, and then all my data that was captured. So you can take this data, you can have a record of your installation, you can plot the data if you like, anything that you can do in Excel for plotting, you have the data to do it for, and all the column headers are shown. So let's go back to the FS200 Utility, back to Diagnostics. At the present time, we're currently developing a report generator tool which will take this data that we captured and create an automatic report. Once that becomes available, I will then amend this presentation to indicate how to utilize that tool. But for the time being, we do provide the CSV file that you can import into Excel to create a record of your application installation parameters, as well as to plot your flow data. So stay tuned. We may ultimately be able to provide you with an automatic report generator derived from the data we can capture here. Also, besides saving a copy of the diagnostic data that you're recording, you can also print a copy, just like with the signal graph, by coming down to the bottom of the screen and clicking print. The FS200 tool will print a copy of what you see on the screen, and again, that will always be to the default printer that's set up within the tool. What you also notice on this display screen of the diagnostics is that all the data is for path 1. Currently, this meter is only configured for one path. However, if it was configured for 2 or more paths, depending on the meter type that you're working with, each of those paths would also be displayed live at the same time. And you would also be able to select what data is shown on the graph screen, whether it's path data or system average data. You can also change the time span of the graph display by coming up to this drop-down box and selecting the time units you wish for the overall time period of the x-axis. You can see right now it's 5 seconds per division, which is a total of 1 minute across the entire screen. If we change it to 5 minutes, that will then change the individual sections to 15 seconds per division. So you can set that up to be configured any way you wish. So that's a look at the diagnostics portion of the FS200 Utility. I hope that helps you make better use of the tool. Be sure to check out all the other videos in this series that cover all the different functions that are available to you in the FS200 Utility software. Thanks for your attention, and bye for now.
Siemens. Ingenuity for life. Siemens. Ingenuity for life.